Welcome. In this video, we'll be exploring the DSP channel tab within the TOA M-8080D software interface. This section provides access to a range of powerful audio processing tools, including equalization, gain, crossover settings, and more, designed to optimize performance for both input and output channels. We'll guide you through each setting, offering a clear overview of their functions and practical applications. Frequency. An EQ selects which part of the sound spectrum you adjust. What it does: low frequencies, bass, equals affects deep sounds. Mid frequencies equals affects vocals/instruments. High frequencies, treble, equals affects clarity and brightness. Why it matters: helps you boost or cut specific tones to improve sound balance. Fixes muddy bass, harsh mids, or sharp highs. Use frequencies to target exact areas you want to adjust. Q factor. Q-fact. An EQ controls how wide or narrow the EQ adjustment is around a frequency. What it does: low Q equals wide range affected, smooth, natural changes. High Q equals narrow range affected, precise tuning. Why it matters: wide Q equals good for gentle tone shaping. Narrow Q equals good for cutting harsh frequencies or feedback. Use Q-fact to fine-tune or shape your sound effectively. Gain. In a 5 to 8 band EQ controls how much you boost or cut specific frequency ranges. What it does: increase gain equals boosts certain frequencies. Decrease gain equals reduces certain frequencies. Why it matters: it helps enhance or fix audio, example, more bass, less harsh highs. It prevents muddy or weak sound by balancing frequencies. Use it to shape the tone for clarity and balance in your mix. Type. In EQ defines how the filter shapes the sound at a chosen frequency. Common types: peaking, boosts or cuts a specific mid-range frequency. Low shelf, boosts or cuts everything below a set frequency. High shelf, boosts or cuts everything above a set frequency. Low pass, allows lows through, cuts highs. High pass, allows highs through, cuts lows. Notch, cuts only a very narrow frequency range, good for removing noise. Why it matters: helps shape the tone to fit your needs. Removes unwanted noise or enhances important sounds. Choose the right type to fine-tune your mix effectively. Compressor. Controls audio dynamics by reducing loud peaks and boosting quiet parts. What it does: reduces volume spikes for a smoother sound. Makes soft sounds louder for better clarity. Why it matters: prevents distortion from loud peaks. Keeps audio levels balanced and consistent. Use comp to make sound clearer, more controlled, and professional. The threshold in EXP/gate is the volume level that decides when the effect turns on. If the sound is louder than the threshold, it stays normal. If the sound is quieter than the threshold, it gets reduced or muted. Think of it like an automatic door: loud sounds open the door, let the sound through. Quiet sounds keep it closed, block the noise. You set the threshold level to control what gets through and what gets silenced. The attack in EXP/gate is how fast the effect reacts when a sound gets louder than the threshold. Fast attack, example, 10 milliseconds, the sound comes through immediately. Slow attack, example, 150 milliseconds, the sound fades in gradually. Think of it like turning on a light: fast attack equals light switches on instantly. Slow attack equals light dims up slowly. Use a fast attack for sharp sounds, drums, speech, and a slow attack for smoother fades. The ratio in EXP/gate controls how much the quiet sounds below the threshold get reduced. Low ratio, example, 2:1, softens the sound gently. High ratio, example, 10:1, cuts the sound almost completely, acts like a noise gate. Think of it like turning down the volume. Low ratio equals volume goes down a little. High ratio equals volume drops a lot or fully mutes. Use low ratios for a natural effect and high ratios to cut out background noise. The release in controls how long it takes for the effect to stop after the sound drops below the threshold. Fast release, example, 10 milliseconds, the sound cuts off quickly. Slow release, example, 1000 milliseconds, the sound fades out smoothly. Think of it like turning off a light. Fast release equals light switches off instantly. Slow release equals light dims out gradually. Use fast release for sharp cuts and slow release for a natural fade out. The flat in EXP/gate resets all settings to default values. It removes any custom adjustments. The expander/gate returns to its original factory settings. Think of it like a reset button. It clears all changes and starts fresh. Bypass turns off an effect or processing without deleting settings. What it does, on equals the signal goes through unchanged, no effect. Off equals the effect is active. Why it matters? It lets you compare processed versus unprocessed sound. It helps troubleshoot or disable effects without resetting. Use bypass to check if an effect improves or harms the audio. 48V phantom power is a voltage sent to condenser microphones and active DI boxes to power their internal electronics. What it does, it enables condenser mics to capture sound. It's not needed for dynamic mics, they work without power. Why it matters, turning it on when needed equals mic works properly. Turning it on by mistake on the wrong device, like some ribbon mics, can damage it. Use 48V only when required to avoid equipment issues. Polarity in audio refers to the positive and negative alignment of a signal. What it does, correct polarity equals sound plays normally. Reverse polarity equals flips the waveform, can cause phase issues. Why it matters, if two signals are out of polarity, they can cancel each other out, weaker or no sound. Keeping polarity correct ensures clear, full audio without phase problems. Use polarity flip to fix phase issues in multi-mic setups. Mic sensitivity controls how easily a mic picks up sound. High sensitivity equals captures quiet sounds. Low sensitivity equals needs louder sounds. Use high for soft voices, low for noisy areas. Mic versus line sensitivity. Why it matters? Mic level is very weak and needs more gain, higher sensitivity. Line level is stronger and needs less gain, lower sensitivity. If you set mic sensitivity too low, it won't pick up enough sound. If you set line sensitivity too high, it can cause distortion. Proper sensitivity ensures clear, balanced sound without noise or clipping. Gain controls how much a signal is boosted before processing. What it does, higher gain equals louder sound. Lower gain equals quieter sound. Why it matters, too much gain equals distortion/clipping, bad sound. Too little gain equals weak signal, noise issues. Therefore set your gain properly for a clear, strong signal without distortion. Low pass filter, LPF, allows low frequencies to pass through while cutting high frequencies. What it does, removes unwanted high-frequency noise. Keeps bass and low-end sounds clear. Why it matters, used in subwoofers to focus on deep bass. Prevents harsh or sharp high frequencies in certain setups. Use LPF to control high-frequency content and improve sound clarity. High-pass filter, HPF, allows high frequencies to pass through while cutting low frequencies. What it does, removes unwanted low-end rumble, like mic handling noise or hum. Keeps vocals and high-frequency sounds clear. Why it matters, prevents muddy or boomy sound in speakers. Improves clarity in speech and instruments. Use HPF to clean up low-frequency noise and enhance clarity. Inputs are the audio sources connected to the M-8080D, like microphones, instruments, or external devices. What they do, bring sound into the system for processing and mixing. Can be adjusted with EQ, gain, compression, and effects. Why they matter? Proper input settings ensure clean, balanced sound. Helps avoid distortion or weak signals. Use inputs to connect and control your audio sources effectively. Outputs are the audio signals sent from the M-8080D to speakers, amplifiers, or recording devices. What they do: deliver processed sound to your system. Can be adjusted with EQ, gain, delay, and compression. Why they matter: ensure clear, balanced sound reaches the audience. Prevent distortion or weak output levels. Use outputs to send optimized audio to the right destination. This concludes our walkthrough of the DSP channel tab in the M-8080D software. Understanding these controls is essential for achieving precise audio configuration across your system. For further guidance on TOA's digital audio solutions or to explore additional system features, refer to the full documentation or contact TOA Tech Support. Thank you for watching.
Dr. Sound. TOA.